All right, 9-4, transforming quadratic functions. I love quadratics. I hope your teacher has told you all the amazing things that quadratics can do. Today we're going to be graphing and transforming them to be building on what you did last lesson in 9-3. Just taking a look, make sure you remember 9-3. Just to figure out the axis of symmetry is negative b over 2a. Remember we have y equals ax squared plus bx plus c. In this case here, there is no b value, so negative b is going to be 0 over 2a, which a in this case is 1, right? So 1 times 2 is 2, so 0 over 2 is 0. So our axis of symmetry is always x equals that value. X equals 0 would be a vertical line, but right on the y-axis. Axis of symmetry of the vertex. To figure out the vertex, you take this value, right? And then you plug it back in. You take this value you figured out, you plug it back in here. And then you get a y value. You get y equals 0 plus 3, so it's going to be 3. So then 0, comma 3 is your vertex. And whether it opens up or down. This one opens up because the a value is positive. If the a value is positive, it is happy. It smiles. Woohoo! It's so happy. The a value is negative. It's sad. It cries. It's so sad. Okay, it opens down. All right. So just making sure you get this quick graph. It's not going to be pretty, but we've got a vertex at 3, and it's opening up. And its axis of symmetry is the line x equals 0, which is a vertical line. Hopefully you have that figured out in your head. This is all the places where the x value is 0. That's the axis of symmetry. And there we are. Moving on with our lives on to this lesson. Okay, parent function of quadratics is y equals x squared, or f of x equals x squared. If you've learned that, axis of symmetry is x equals 0. The vertex is at 0, 0. And how many zeros it has. Zeros is the same as x-intercepts, the same as roots. You're going to hear a lot of words for this, but every time it crosses the x-axis, how many zeros? This one has 1. You can have 1, 2, or 0, right? This would be a parabola with 0 zeros. Doesn't cross the x-axis at all. The parent function, when I just wrote the equation for, this one here, has 1, or it could have 2, right? That's the ugliest parabola ever. Moving on. All right, so we're taking a look at these functions and trying to figure out how they relate to each other. At this point, really, you should do these, pause the video, do these on your own, figure out what they are, and come back. I want you to actually graph these 3 with different colors on the same coordinate plane. Figure out some points just like you did last time, get your axis of symmetry, find out a point, and graph them. All right, so pause it now, please, and go ahead and do that. All right, and now we have them graphed. Should be able to take a look at what's the same, what's different. Oh, they're all parabolas, right? They're all parabolas. They all open up. Okay, they all have the same vertex. But what's different is how fat or skinny they are. Okay, we have some that are obese and some that have obviously been working out. I color-coded them for you. Green one is my 3x. You may have chosen slightly different points, but you should. All of your graphs, you should be able to see that this one here is the skinniest, this one's the fattest, and this one here is in between them. All right, so then trying to figure out what we can base on that. It's all the only thing that changes is our a value, right? Ax squared, the only changes is the a value. It looks like the bigger the a value, the skinnier the graph, right? The bigger the a value, as a goes up, the graph gets skinnier. And as a goes down, it gets fatter. Okay? A go down, it gets fatter. And that's all we can really figure out from that for sure. We'll take a look and see if we can figure out some more things based on some more graphs. Okay? We have another set here. We have these 3 up here at the top, and we're going to do the same thing. We're going to graph them. I'd like you to pause the video and then go ahead and graph them, and then we'll come back. So go ahead and pause it now. And we're back. And if you take a look at the graphs, hopefully your graphs look similar to mine. All right, we've got the 3 graphs. We're taking a look at what's the same. Well, they all open up. They're all actually kind of the same level of fatness. We want to think about the last one, same level of skinniness. Okay, they aren't stretched horizontally or vertically. But what's different about them is their vertex. The vertex moves up and down. And if we take a look at what changed in the equation, we have x squared plus 0. Here we have x squared minus 2, and here we have x squared plus 3. And if you can take a look, you should be able to see a relationship between this 0, this minus 2, and this plus 3 in the graphs. Take a look. Do you see it? Do you see it? Do you see it? 0. There is at 0, and there is at negative 2, and there is at 3. This c value, right, it's ax squared plus bx plus c, right? And this value here on the end, this c is the only thing without an x. So this is a c value, this is a c value, this is a c value. Okay? The c value seems to tell us where the y-intercept is. Okay? It moves it up and down. Okay? So that's what looks like the c value is going to shift our parabola up and down on the graph. So we can make it skinny. We can move it up and down. See if we can do anything else with it. All right, we've got two functions. Taking a look at this one, you should be able to make a prediction based on this before we even start. I hope you can make an educated prediction based on that plus 2 before you start. I'm going to have you do the same thing. I'm going to pause the video and graph it, and then we'll come back. All right, and we're back. I decided that maybe I should help you a little bit with the graphing the second one. I chose to put, at first I found my vertex by putting in 0, right? You put 0 in for x, you get your vertex here at 2. All right, that wasn't a hard thing. Put 0 in for x, right? You get your vertex of 0, 2. And then after figuring out my vertex, I decided that I wanted to use some multiple of 3 for my x squared, just to make life easy on myself so I could take a third of it. You could have put in anything, but just to make my life easy, I did negative 1/3 times 3 squared, put in 3, right? Plus 2, and 3 squared is 9, and third of that is going to give me a negative third of that. Gave me negative 3 plus 2, which gave me negative 1. Okay, so then I plotted negative 1 here and here. Okay. Anyway, if you take a look at those graphs, it does look like we have our vertex at 2, which makes sense based on this, right? It moved up 2. It looks like it is kind of fat, which makes sense because that's 1/3. We said as a goes down, right, it gets fatter. But there's also, it looks like it's been flipped upside down. And that shouldn't be too surprising, I think, because we talked about whether it opens up or opens down depends on whether or not a is negative. So because this is negative, it opens down, okay? So we can flip it upside down by making a negative. We can make it fatter. We can move it up and down. The only thing you can't do so far is move it left and right. We will eventually get to that, but not quite yet. So summarizing all that fun stuff, I can try to make this a little bit bigger so it's more legible. All right. The absolute value of A is bigger than 1, then it gets narrower or skinnier. Okay, so that means that if, like, say you had negative 3. I don't want you to think that negative 3 is going to be really fat because it's really low, right? Negative 3 is still going to be skinny. It's just going to be skinny facing upside down. And then if A is less than 1, the absolute value of A is less than 1. Basically, it's a fraction. If you're a fraction less than 1, not like 3 halves, but if you're, say, let me get my pen back here. All right. Like if you are 1/4 or 1/2 or 2/3 or negative 2/3, if that's your A value, then you're going to be wider. Okay. If your A value is negative 3, well, then you're skinny and upside down. If it's 2, then you're skinny and right side up. This one will be skinnier than negative 3 will be skinnier than 2. Okay, the bigger it is. Moving it up and down, like we said, all has to do with the c value. If the c value is positive, if you're adding, like if it's x squared plus 2, you're adding a positive here, then it's going to move up. If you're adding a negative, then it's going to move down. That makes sense. Right? It's really what you think would be the case is the case. It just makes sense. As far as why these are steeper, why this is steeper, you can think this a value, if it's y equals 2x squared, it's going to make this 2 is going to make the y values go up faster, which makes it skinnier. Right? That's why it does it. Hopefully you can understand and see why it is what it is. Moving on. Ordering the functions from the graph from narrowest to widest. Well, the narrowest, the skinniest, is going to be the one that has the highest A value in absolute value. So the highest A value is going to be this one. We've got a 6. And then after that, it's going to be this one. Once again, you got to think in absolute value. This one's still going to be pretty skinny. It's just going to be flipped upside down. And this one's downright fat. It needs to go on a diet. Okay, because we have 0.2. 0.2 is a fifth, right? So we're very, or 2/10, which is a fifth. So we're relatively wide in that case. And hopefully, like I said, you can see why. This 6 is going to cause the values of g of x, the values of y, to increase more rapidly, which is going to make it skinnier. Number 2, trying to put them in order again. All right, what value is sitting right here is a -1, right? So -1, well, -1 is bigger in absolute value than 2/3. So the first one would be here, and this would be 1, and this would be 2. This one's going to end up being the fatter of the 2. All right, comparing the graph with x squared. Okay, we're trying to say what's different about this one. Well, because the a value is negative, or ax squared plus bx plus c, the a value is negative, that means it's going to be flipped upside down. So it's flipped. And I would say flipped across which axis would be best. It's flipped across the x-axis. And then this -4 is going to be shifted down 4. Yeah? And then this last one, at 3, what's the 3 going to do to the thing? It's going to make it narrower. It seems to be the word that we like to use, skinny. Fat, that's all good. So it's going to make it narrower, okay? It's going to make the thing skinny. All right, and then the +9 is going to shift it up 9. Simple enough. You know, so if you're just graphing this thing real quick now, you should have like an idea. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's way up here somewhere, and it's really skinny. You know, super skinny, way up there. That's what that probably looks like. All right, moving on. Oh, that's it. Hopefully you get this. It all makes sense. All we're doing is to try to recap the whole thing. If I'm going to write this down again, ax squared plus bx plus c. If a is positive, then it opens up. If a is negative, then it opens down. If a is the absolute value of a is bigger than 1, then it gets skinny. If the absolute value of a is in between, is less than 1, it's like a fraction or a decimal, like 1/4, then it's going to be fat. Okay. If c is positive, then it's going to be shifted up. If c is negative, then it's going to be shifted down. Okay. Really, we haven't even messed with b here. We're not messing with b so much in this lesson. The only thing you guys know about b so far is -b over 2a is going to give you your axis of symmetry. Yeah? That's that. Okay, thank you very much.